Hello, welcome all. Myself Kiran. I am from Department of ISP Today we will learn about memory management. Come, let us dive into the topic. First, let us see the outline: introduction, memory hierarchy, paging, segmentation, virtual memory, page replacement algorithms, and memory protection. And we end the session with the conclusion. First, let us see the introduction. Why memory management matters in an OS. OS is nothing but an interface between an hardware and application program. That is, OS helps the user to interact with the applications very efficiently. Okay, and the memory management is like a traffic controller of our computer's memory. It ensures that computer memory is used efficiently, just like a cop keeps the traffic flowing smoothly. That is, what is the job of memory management is memory management makes sure that data flows in and out of the memory very smoothly, efficiently, and effectively. And the key objectives of the memory management are efficiency, security, and reliability. Ensure efficiency is nothing but ensuring that memory is used optimally to run the program quickly. That is, you have to use the memory efficiently, right? It is a memory is the precious thing, so you have to use it very efficiently in order to get the output. And the security, preventing unauthorized access to sensitive data that is stored in the memory. And it is security is also very essential, so that no other person can access except the user. And the reliability is ensuring that computer operates without crashes or errors caused by memory issues. Okay, and in simple words, memory management is vital to keep your computers very running smoothly, safely, and without any hiccups. And memory hierarchy is how the different kind of memory is arranged at the different level. Okay, first let us see the cache is at the top of the pyramid. And think of this as your computer super fast but tiny notepad. Okay, and it stores the most frequently used information, and so your computer can access it at lightning fast. This cache is very fastest. Okay, so the processor can access it very fastly, and it stores the most frequently used information. Okay, and the RAM, that is main memory, it's in the middle of the pyramid. Okay, and the picture this as a larger notebook. You can visualize it as a larger notebook where your computer stores the things that is currently working on it. That is, if you want to execute any of the programs, we have to load that into the main memory, and it's faster than the bottom level but not quick as the top. That is, it's faster than the secondary memory but it's not fast as the cache. Okay, and let us come to the disk, that is bottom of the pyramid. And this is massive bookshelf where we can visualize it as a massive bookshelf where your computer stores everything it knows. Okay, and even its stuff it's not currently using. Okay, and it's slower to access but as ton of spaces. That is, it has the disk has very huge amount of space, but it's very slower. And and it takes lot of time to access. It takes lot of time to access, it's it's non-volatile. That is, even the power when the power is off, it does not loses its data. And let us see understand with the help of the diagram. As I told you, that cache is at the top, and there are cpu registers are very fastest when compared to all those things because it is present inside the cpu. Okay, and next comes the cache and the main memory and the secondary storage, that is disk, optical disk, and magnetic tape. Okay, and as we go up, the speed increases very rapidly, and the cost also increases rapidly because the speed is more, right? Okay, and and as we come down, the speed decreases, but the storage capacity increases as we come down. The size of the cache is very less when compared to the what is it, the main memory and optical disk. And the same thing, the secondary storage is size of the secondary storage is very high when compared to cpu registers and the cache. And the memory partitioning, that is dividing the memory for efficiency. Memory partitioning is like dividing a pizza to share. Okay, I'm giving just an analogy for visualization. Okay, and we have the two partitioning, that is fixed partitioning and dynamic partitioning. Think of the think that is into fixed partitioning, think of it as slicing the pizza into two equal pieces. Each of the slice has fixed size, and the programs are like people grabbing a slice. Easy to manage but can lead to wasted space if the slices are too big or too small. That is, we are dividing the memory into fixed spaces so that process can make use of the memory. Suppose a process requires suppose we are dividing the memory into 10 MB, okay, and suppose a process requires a 5 MB, and it we are allocating the 10 MB space. So the process is utilizing only 5 MB, right, and other 5 MB gets wasted. And this is the advantage of fixed partitioning, that is, sometimes the space may get wasted even when it is not used, okay. And dynamic memory is, imagine a cutting a pizza into slices of different sizes depending on whose hunger. This is flexible but needs a more complex system to keep track of the pieces. That is, we are providing the memory to the processors according to their wish, that is, according to their desired size. That is, if the process requires 5 MB of space, we are providing only 5 MB of space, not exceeding that. Thereby, we are using the memory efficiently. But what is the disadvantage is where it is more complex system to keep the track of the pieces. That is very difficult to implement this dynamic partitioning. And let us see the paging. Paging means the organizing the memory like a book. Paging is like organizing a book into pages. Instead of slicing a memory into fixed chunks, we cut it into small, equal-sized pages like pages in the book. Each program gets a page or several pages. We used a page table to keep track of which page belongs to which program. That is, we are dividing the memory into pages, and these pages uh, these pages are allocated to the process, and we can assume the main memory as one book, and we are dividing the main memory into what is that small segments, like we can assume it as a pages. And how we access all the pages? With the help of a page table, that is where it is having the page index values. And think of the page table as index at the back of the book, telling you which page to turn to for specific information. By using the pages, we make sure the memory management is more flexible and efficient. It's like finding the information in a book quickly by flipping to the right page instead of searching through a huge pile of papers. Okay, page table helps us to access the pages very quickly. That's the advantage of this page table. And I had given a simple diagram where the main memory is divided into two segments. That is, one is operating system, and we can't test that thing. Okay. The other thing is the user utilization. That is, user can utilize this space, and it is divided into pages: page 1, page 2, up to page 9. And there are some of the processors at the right, and these processors will be getting the memory spaces, okay. And it is mapped to the main memory. And segmentation memory segmentation, organizing like uh, organizing the memory into it is like organizing the memory like dividing a book into chapters. That is, we are not dividing the memory into equal parts as we done in the paging. Instead of equal sized papers, we have segments which have different chapters in the book. That is, in the paging we divided the memory into equal sized part, right? But here in the segmentation we are not dividing the memory into equal size parts. We can assume the segmentation as dividing the book into chapters and the paging as dividing the book into pages. And the benefits of this segmentation is help separate parts of the programs logically, like chapters separate topics in the book, allows for flexible memory allocation like having a different sized chapters. And what are the drawbacks of this is can lead to memory fragmentation like having gaps between the chapters in the book. Managing segments can be more complicated compared to paging, which is like flipping the pages into a book. And let us see the virtual memory. Expanding your computer's memory, virtual memory explained. Okay, think of the physical RAM, that is random access memory as a desk where you can work with the papers. Okay, now imagine you have more papers that can fit on the desk. What you want to do, you have to use a shelf, right, to store the extra papers and bring them back to the desk when needed. Virtual memory is like a shelf. It's it's a space on your computer disk where it stores the data that doesn't fit in the physical RAM. That is, suppose you have one, suppose the size of the program is very large when compared to the size of the main memory, and so we can't load the whole program and the data into the main memory, right, in that case. So we have to store the data in order to execute the program, right? So we are extending some part of the secondary storage to store the data, and when we need the data, we are loading that data from the secondary storage into the main memory. Okay, in order to execute. Okay, and the the place where we store the data in the secondary storage, when we want to execute the data, that space is called virtual memory. And this way the virtual memory expands your computer's workspace, allowing it to handle larger tasks, just like having a big shelf for extra papers when your desk is full. And the page replacement algorithm, there are page replacement algorithm, that is least recently used LRU and FIFO, first in first out. What are the pros? Keeps the most recently used pages on your desk, reducing the chance of needing to fetch them from the shelf often. Cons, what is, it can be tricky to keep the track of the exact order of the page usage, which may require more memory. And let us come to the second one, FIFO. Pros: simple to implement, and it's like a queue, and where the first book you put on the shelf is the first on you take out. Cons: it may not always keep the most relevant pages on your desk, leading to leading to more pages leading to more page swaps. That is, when we use it before, the number of page points is more. And let us understand the FIFO with the help of the diagram. Consider a page reference 1303563. Okay, and we have three frames, and we want to, and now we bring one, and it's a page miss. And now we bring the three, and it's also page miss. And next let us bring the 0. uh, it's also page miss. And next let us bring the 3. It's already there, okay, inside the main memory. So we are not required to bring the 3, and it's a page hit, that is the data is already available. And next we have to bring the 5. In order, already the three frames are completely filled. Okay, in order to replace any one of the data, we are using the page replacement algorithm, that is we are using the FIFO. Okay, among the 031, which came first? 1, right? So we are replacing the 1 by 5, and this is also page miss. Okay, and we are bringing the next we are bringing the 6 among the 0 and 3, which came first? That is 3. So we are replacing the 3 with 6, that is we are following the FIFO rule. And next we are replacing the 0 with 3. Total number of page faults is 6. That is, this is what the disadvantage of using this FIFO algorithm, that is the number of page faults will be more. So this is the drawback of the FIFO. And let us see the memory protection. Memory protection is like setting up locked doors and security cameras in your home. It sets up the rules that prevents the programs from messing up with each other's data or causing memory errors. That is, memory protection is nothing but utilizing the memory so that uh, the data and the programs are executed properly, and preventing unauthorized access. Think of your computer as a building with many rooms. Memory protection ensures that one program can't barge into another uh, program's room without any permission. This keeps your data safe, and just like locked doors keep the unwanted guest out of your home. And we end the session with a conclusion, that is, memory management is like making sure that everything in our computer's memory works smoothly like a traffic controller for the data. That is memory management. It manages the data in the memory, and it aims for three main goals, that is efficiency, security, and reliability. Effective memory management is crucial because it ensures that computer runs programs quickly and efficiently, like well organized workspace, and it helps your data to be safe from unauthorized access, similar to locking a door, and it prevents errors and crashes, making your computers reliable, like like a trustworthy friend. Thank you. And if you have any doubts, feel free to write the comments in the comment box. I will be there to help you. I hope you enjoy the session. Thank you.